The warm-up, I asked you to find me these pieces. X-intercept, Y-intercept, horizontal asymptote, vertical asymptote. So somebody share with me one of the pieces that you found. Say again? Which is?
Oh, not vertical. Horizontal.
Okay, you found horizontal asymptote, which is Y equals? 2. And how did you get that?
The 4 over 2.
The 4 over 2. This is same over same. What do I mean by that? Because some of you are going, that's not the same two numbers, but it's the same two exponents. It's x to the first and x to the first. All right? So 4 over 2 is 2. All right? Somebody else, give me another piece.
The vertical asymptote
Is?
x equals 3.
Vertical asymptote is x equals 3. The vertical asymptote is when the denominator is 0. Right? So 2x minus 6 equals 0. Some of us can look at that and just tell me it's 3. That's fine. If not, move the 6, then divide by 2, and I get x equals 3. Now here's the thing. The denominator and the domain go together in this problem. Okay? The denominator and the domain go together. My domain is all real numbers except what causes the bottom to be 0. So here's how I would say this. My domain is all real numbers except x can't be 3. Because at 3 it's undefined and I have a vertical asymptote. Alright? So vertical asymptote and domain go together. If you get one, you got the other. Alright? Everybody okay with that? What is the, what's another one? What's the easy one out of these two? Normally the y-intercept's the easier of the two. So I'm going to put 0 in for x, 0 in for x, and I'll get 1 over negative 6. So 0, negative 1/6 is my y-intercept. All right? How do we get the x-intercept? Put y equals to 0. I don't know if you're tired of me asking that question or not, but every time I ask about intercepts, we've got to know there's a 0 involved. Okay? Now, this one was pretty easy from yesterday because what did we do? We multiplied, right? But 0 times anything is? 0. These canceled. And basically, it's the numerator equal to 0. All right? Minus 1. Divide by 4. And that is my x-intercept. Okay? Everybody okay with the pieces? Now, I have not given the range because most of the time I want to see the picture to be able to give the range. Okay? So let's sketch a picture. So if I'm sketching this, I know my vertical asymptote is at 3, x equals 3. I know my horizontal asymptote is at y equals 2. All right? I know I have a y-intercept at negative 1/6 and a x-intercept at negative 1/4. Now, technically, I think you probably know where this graph is going, just because of the things that we have already. This makes sense. How do you connect these together? You're going to connect them together like that, and then it's going to run that horizontal asymptote there. So that piece, I think we're good on. Now, typically, they're opposite, so I should have the other piece up here. But the way that I verify that is we use our sign chart and we use our critical values. What are the two types of critical values again? X-intercepts and undefined. What is my x-intercept? Negative 1/4. What is my undefined? X equals 3. It's the vertical asymptote. Okay? Have we already plugged the 0 into there?
Yes.
We did already, and it gave me negative. Which makes sense. From negative 1/4 to this asymptote here, where is the graph? It's in the bottom. It's underneath. Okay? I would go here. Pick 4. All right? Okay. All right? I'm going to plug in a 4. So if I plug in 4, that's going to give me a positive on top. That's going to give me 8 minus 6, which is positive on bottom. So positive over positive is positive. So this has to be above the x-axis. Now you're going, some of you might be going, well, isn't this above the x-axis if I put it there? Well, where's that line gonna go? Correct? So I don't want it there. It is gonna run the horizontal asymptote, but it's gotta be up here to make it work, right? Same thing over here. I would pick a -1, plug it in. -1 times 4 is -3, plus 1 is a negative on top. -1 times 2 is a negative with another negative, that's negative on bottom, so negative over negative is positive. And I'm above the x-axis there. Okay? Everybody all right with that? Okay. Here's what I'd like for you to do. I'm going to give you about a minute. I want you to write that problem down there. X plus 4 over x squared minus 4. I want you to find me the vertical asymptotes, horizontal asymptotes, x-intercepts, y-intercepts. You're finding me the pieces. There's two easy ones, two difficult ones. Or not difficult, but more complicated ones. Okay? Finding me the 4 pieces here. All right, I hear some good conversation. All right. I think there are 2 pretty easy ones to find to start off with. What's a pretty easy one to find up here?
Horizontal asymptote.
The horizontal asymptote. What is it? It is 0. The horizontal asymptote is 0. And why is it 0? It's small over big. I have an exponent of 1 on top, exponent of 2 on bottom. It's small over big, so it's always y equals 0. Okay? What else is a really pretty easy one to find? The y-intercept's pretty easy. What is it? It's -1. Yeah, somebody said from the back. 0 there, 0 there. I've got 4 over -4, which would be -1. All right? Those are the 2 pieces I think that are pretty easy on this one. Okay? Now, did anybody come up with one of the other ones?
Vertical asymptotes 2. X equals 2.
Okay? You're half right. There's 2 of them here. Okay? There's 2 vertical asymptotes here. Now, what do you mean? What's going on? Where do my vertical asymptotes come from? When is the denominator equal to 0? So some of you can look at it and go, what number do I square? Minus 4 gives me 0. So 2 squared is 4. Minus 4 gives me 0. Or you can write it out. X squared minus 4. When is the denominator equal to 0? I think there's 2 ways to solve this. What could you do with this? You could factor. It is x minus 2 and x plus 2. We call that difference of 2 squares. There's your 2, there's your -2. All right? Or you could take the 4, move it to the other side. So add 4. Then what? Square root. Don't forget to do plus or minus. There's my 2 and my -2 there as well. Okay? All right, that. So I have 2 vertical asymptotes on this one. I have 2 undefineds. X-intercept. Not hard, but just takes a little bit of work. Some of you are kind of getting that hang of it. Does it matter that this is a little bit more complex here?
No.
When I multiply by it, it can be as complex as I want it to be. If I multiply by 0, it's 0. So I would have that, then move my 4 over, and I got that right there. Okay? Now, I've got a good information about the graph so far. Any questions about those 4 that you need me to go back and address a little bit? We okay? All right, so let's sketch. So what do we have? So I have a horizontal asymptote at 0. I have a vertical asymptote at 2 and at -2. Okay, horizontal asymptote is 0. I've got vertical asymptotes at 2 and -2. I have a y-intercept at 0, -1. And I have an x-intercept at -4, 0. Anything concern you about the graph that I just drew? What concerns you? The fact that there's 2, okay? Anything else?
Which way does the middle one go?
This right here concerns people. I have a horizontal asymptote at 0, and I have a root, which is also at 0. You may cross horizontal asymptotes. You just cannot cross vertical asymptotes. Vertical asymptotes is where it's undefined. So you can't cross those. You can cross horizontal. Now, what does horizontal asymptotes mean? I gave you that term a little bit yesterday. It's in behavior. What is it doing far to the left? What is it doing far to the right? I don't care what it's doing in the middle. All right? So the horizontal asymptote tells you what's going to happen on the graph way over here, what's going to happen on the graph way over here. And it's going to go to 0 is what it's going to do. Okay? Now, I'm going to go build me a sign chart because this is a little bit more complicated. And I'm going to put my critical values on my sign chart like I've been doing. What critical values do I have? 2 and -2. What type of critical values are those? Vertical asymptotes. That's where I'm undefined. All right? Something's up with the graph there. What else is a critical value? -4. The x-intercepts. Good. -4. Now, this is a little bit bigger sign chart, correct? We've got a few more critical values. It's a little bit more complex. All right? So, I'm going to do this piece right here because this is the easy one. I'd put 0 there, which I've already done. And it's a negative on that piece. All right? Again, you see what I'm doing. I'm trying not to rework anything. I'm trying to take advantage of the things I've already done. I'm going to pick 3 and put it over here. 3 plus 4 is 7, so it's positive on top. 3 squared is 9 minus 4, which is 5, so it's positive on bottom, so positive over positive. You notice I don't even care what the numbers are. Okay? The only number that I'm going to pick between -2 and -4 is -3. Now that's not the only number there. I just don't want to plug in a decimal. Okay? So -3 plus 4 is 1. It's positive on top. -3 squared is 9 minus 4 is 5 on bottom. So I've got a positive on top and a positive on bottom. So it's positive. Now, if you need to write this down, that's fine. I'm just doing the middle math right now, all right? But write it out if you need to. I'm going to pick -5 over here. -5 goes in up there. -5 plus 4 is a -1, so I'm negative on top. -5 squared is 25 minus 4, which is a positive 21. So I got negative over positive, so I'm negative there. Okay? Now, my sign chart doesn't always have to switch. It could have 2 positives next to each other or 2 negatives. Right? In this case, it's just alternating. Okay? So let's do this. Here is 2. This is my critical value. I'm above the x-axis, so I'm here. As I go to the right, I'm going to approach 0. So it's going to level off at 0. In the middle, between my 2 asymptotes, it's negative. So between the 2 asymptotes, it's negative. So it's going here and it's going there. Why did it go up here? 2 reasons. It's negative, it's not positive, and what are my roots? That's my only root. If it went through the x-axis, I would have another root here. Make sense? Because it doesn't have to look like there's some crazy things it can do in the middle. All right? Then from -2 to -4, that's a really small window. -2 is my asymptote, -4 is my root. It's positive, so it's here. It is going to cross, but then it's going to level out as it's going to infinity. It's going to go back to 0. Okay? It's not going to touch 0, but it's going to be really close. That's a pretty complex graph. Now, could we have probably done that last year in algebra 2? A little bit more difficult. We didn't have the sign chart, so that was a little bit, we had to just pick a lot of points and test them all right? We have to test a few points, but I'm not testing a whole lot of points. Okay? Now, I want to verify this in the calculator. Any questions before I go on, before I verify the calculator? Ask it. Which part? Okay, so I'm not worried about the shape of the parabola really as much as it is negative. All right, so this has to stay here. It's got to go up and get that point and go back down. Because this is negative, I'm not going to be in the positives at all. Okay? Because of that negative. That's why it's acting the way it's acting there. Good? This part is positive, so it's above the x-axis in that little window. And it's negative here, so it's below the x-axis there. All right? That's all the positives and the negatives are telling me. Okay? So let's go to our calculator. I'm going to go on. I'm going to go new. Okay? Or home and new. No, don't save what you have there. And we're going to go add a graph. Do fractions. I'm going to go control division. You ought to have your calculator in your hand. You ought to be following along. That's where we're all right now. Okay? So I'm going to type that in. So I'm going to go x plus 4 over x squared minus 4. There's my graph. So I'm going to go and hit enter. When I hit enter, then there's that graph. Now, somebody in the last class says, well, that doesn't look like a parabola. It looks kind of weird. Yeah, because it's like skewed because it's not really a parabola. We see a parabola in it, but it's not technically a parabola there. Okay? Well, matches pretty well with what we got. Do you see where the vertical asymptotes are? Because that's where the graph is broken apart. Okay, so where the graph is undefined, that's where my vertical asymptotes. It's not going to draw the vertical asymptotes in the calculator. Okay? Questions about that? Could we go find x-intercept, y-intercept, and all that kind of stuff if we need to? Find your roots. You can do that. Okay? All right. Here we go. I'm going to do another problem real quick. Here is the next one. X squared minus x minus 6 over x minus 3. And I'll do this one a little bit backwards. I'm going to do this one in the calculator first, and then we're going to go back and look at what it looks like by hand. Okay?
Are we going to have the calculator on the porcelain photo?
Probably not, because I think it's going to be kind of the other stuff. It won't have anything quite as complicated as this. All right, you can go and type it in your calculator. All right, so I'm going to move. I know you were copying, but I'm going to go here. I'm going to go up here. I'm going to delete that one out. I'm going to put another one in. So I'm going to go control division. Sets that up for me. I'm going to go x squared minus x minus 6 over x minus 3. Okay? I'm going to hit enter. Thoughts? That's not really the graph I was expecting, correct? I would have expected, it looks a whole lot more complex than a linear function. All right? Should there be a vertical asymptote on this? Is it undefined? We can't use 3, can we? All right, we'll come back to that here in a minute. All right? So now, I want to go and look by hand. Why did we get this picture? Why didn't we get something else? Okay? So, let's walk through. not that, but this. Okay? So let's walk through this. All right. So if I were going to answer some of the same questions that I've been asking, so if we're going to go find our horizontal asymptote, vertical asymptote, x-intercept, and y-intercept. So we do like what we've been doing. Okay? Somebody recognize the horizontal asymptote. What is it? It's big over small, which is what? Yeah, it's a slant asymptote. Which, what did we see in the picture? It was a slant, right? It wasn't flat, it was slant. So this is going to be a slant asymptote. You can't have both of them. You can't have a horizontal and a slant at the same time. You're going to have one or the other. So in this case, it's going to be a slant asymptote. All right? What's my vertical asymptote? Should be 3. X equals 3 because that's what causes the denominator to equal to 0. Okay? You just put slant. Okay? Typically, probably the better question would be, what's the end behavior? And you would say y equals 0 if it's horizontal asymptote, or you say y equals x plus whatever, all right, if it's a slant. Okay? So we're talking about the end behavior.
But we're not like solving it to get to y equals.
No, I'm not going to solve it right now. Okay? All right. Because we'll see something else in this in a second. All right. The other thing, this one's pretty easy. 0 there, 0 there, 0 there, which leaves me -6 over -3, which is 2. So 0, 2. Okay? What is my x-intercept? How have we been doing that? Put 0 in for the y. What's been our next step in doing this? Multiply by x minus 3, which is going to cancel over here. X minus 3, that's going to cancel there. So 0 equals this. We're going to factor that. That's kind of what was on the last test. What two numbers multiply for -6 and add for -1? You could use 6 and 1, but be careful that adds for 5. Okay? So my x-intercepts would be -2 and +3. Okay? Now, anybody have any concern about those?
How's that an x-intercept if it's just a linear line?
How's it an x-intercept? How do we have two x-intercepts? If it's linear? Okay? That's good. What else? That's where it's undefined, correct? If it's undefined there, then how do we have a point there? Okay? So now, look at the rest of this. So if I took the equation that we have, we factored the top, there's what the bottom looks like. What could I do? Those look the same, those can cancel. So essentially I have this. Well, what's that? That's the line that you see in your graph. Okay? Now, but can I disregard the whole 3 deal? Something's happening at 3. This is no longer a vertical asymptote. If I can cancel the undefined, this creates a hole in the graph. It's still undefined, but it creates a hole in the graph. Now, the older calculators, all right, you could graph this and then you could zoom in and it would leave a pixel out, like it would jump, like you're walking along and there's a hole in the sidewalk and just step over and keep on going. That's essentially what's happening here. There's a hole in the graph. The newer calculators, they're not as pixelated, so it's hard for me to show you that, but this is how I can show this, all right? If I were to do this right here, if I were to go menu, and I were to go trace, and go graph trace, remember that shortcut I showed you earlier, just type a number in, so at 1, 1, 3. All right, that's the point. If I wanted to find the y-intercept, I put a 0 in for x, and the y-intercept is 2. We got that one go. Well, if I want to go x equals 3, tells you it's undefined. It tells you it's not there. It doesn't exist. Okay? And so I can see that as going. Everybody good? And so if you have an undefined and some way through the problem you can cancel it, it's a hole in the graph. If you can't cancel the undefined, then it's still that vertical asymptote. All right? So that's what we're seeing there. All right. Moving on. All right, here you go. I want you to copy this down. All right? Copy this one down in your notes. That is an A. All right, y equals A over x minus h plus k. All right. This would be our transformational form of that reciprocal. Okay? This would be our transformational form. Now, where are my parentheses? My parentheses are in the denominator. Okay? So my parentheses would be in the denominator. So what would the A, if I change the A, normally it would be a 1. That's the parent function. But if I changed it to some other number, what would the A do to my graph?
Stretch it or compress
Which way?
vertically.
Vertically. So this is a vertical dilation. I'm going to call it a dilation, so I have to write both compression and stretch. So it's a vertical dilation or reflection. Okay, so if it was a negative, it would vertically reflect it. So the A value, it's outside the parentheses. That's a vertical dilation, stretch or compression, or it's a vertical reflection if it were a negative. Okay? The H value. What does the H do? That's my left and my right. And it works opposite of my normal thinking. So that's left and right. And my K value is up and down. Now, there's actually a little bit more detail in here if we'll kind of focus in. All right? If I move my H, and I'm going to move my graph left and right, yes, all the points move left and right. Okay? But what more specifically moves left and right? X-intercept. The vertical asymptote moves left and right. Where's my vertical asymptote normally? On the parent function, that was at 0. My vertical asymptote is moving left and right. So this number right here, this H, that is my vertical asymptote. That H would be my vertical asymptote in transformation form. Okay? What would your K be? That would be my horizontal asymptote. All right? So if I have my horizontal asymptote normally at 0, if I'm moving it up and down, then that's going to move my horizontal asymptote. Okay? So the K value gives me my horizontal asymptote. Okay? So we're going to do a problem. We're going to graph a couple problems in transformational form. Okay? All right. Sorry, I went the wrong way. Here we go. Copy this equation now. Y equals 2 over x minus 3 plus 2. All right? Y equals 2 over x minus 3 plus 2. All right. Couple little things on this one. What are my transformations that you see in this problem? Up to. And that's this 2 that you're talking about. Okay?
Let's do it in our test tomorrow. We don't have a test or a quiz
Yeah.
on Friday.
Yeah. Right, what? 3, that's that one. Okay? And then what does this do?
Vertical stretch.
That's my vertical stretch by 2. Okay? Now, I want to answer some of the same questions that I asked earlier about the graphs. So we want to know horizontal asymptote, vertical asymptote, x-intercept, and y-intercept. Okay? So we want to know those pieces from this format. Okay? What is your horizontal asymptote? Now, sorry, y equals 2. All right. Now, y equals 2. Now, let's talk about this real quick. Somebody going, you put 0 up there and 0 should be right. Because what is this? Small over big, right? Because this is x to the 0 power, so that's a 0 over 1. So that's small over big, so shouldn't it be 0? Yes, but what's over here? Plus 2. It is 0 plus 2. Because what's the difference about the transformational form? It's not just a single fraction, correct? It's a fraction that's got another number off to the side. Now, how many of you want to go find common denominators and put them together? Yeah, I don't want you to do that either. So we can do this. So that follows my format. That's 0, and then plus 2. All right. What is my vertical asymptote? X equals 3. Okay. Now, my horizontal asymptote, excuse me, my vertical. Got your attention? My y-intercept's still pretty easy, but there's just a little bit of an extra step. Because if I was going to do a y-intercept, I'd plug 0 in here, and I would have 2 over negative 3, but then I also have to add that 2 to it. All right? So negative 2/3 plus 2, you could call that 1 1/3. You could call that 4/3 if you want to write it improperly, improper fraction. You call it 1.3 repeating. I don't care. Yep. Any of those would be fine. Now, there's just a little extra step there because it creates a mixed number, not just a fraction. Okay? Now, this is the one thing that is a little bit tricky, and I'm going through this because it could show up on the quiz on Friday. All right? If I'm looking for my x-intercept, 0 goes for y. So I get this problem right here. How do you solve this? Subtract 2. Okay. So we've been multiplying by the x minus 3. So I do x minus 3 on this side and x minus 3 on this side. Now, what's the only bad thing about it? What have we been having over here? It's been a 0, so that's simple, pretty easy. But I actually have to do that multiplication. So distribute that, negative 2. So negative 2x plus 6 equals 2. So again, we subtracted the 2. We multiplied by the denominator. But now we actually had to distribute this time. Then I'm going to subtract 6. And negative 2x equals negative 4. And x would equal to 2. So my x-intercept is 2. So, y equals 2. X equals 3. And I have 0, 1 1/3, 2, 0. There's where that goes. And when I'm graphing in transformational form, they're in opposite quadrants. Okay? All right. If I graph this one, I'm not going to graph it, let's just talk about it. What would happen in this one? What are your transformations? There's a vertical reflection. So I would take this piece and move it here, this piece and move it there. And it would be right 2, so I'd move it right 2, and then I'd flip it like that. Okay? All right, sorry we went a little bit longer today. Your homework tonight, page 191 and 199. I know I'm kind of jumping around a little bit, but do the problems that's listed next to 191 and 199. We'll say 195 for tomorrow night, okay? So 191 and 199. 191 should take you probably about 5 minutes. It's not really complicated, all right? Matter of fact, I'm going to put up on the board real quick. All right, one last thing as you're packing up.
He said minus 6 and he started leaving.
All right. Your attention. As you're packing up, question C. How would you go about graphing that? What would you do first? Divide by x, then it will make it look like this, and then I could go graph. All right? Divide by x. Now it would look like these, and now I could go graph. Okay, make sense?